Okay, so today we continue on with lesson 6.3 part 2, problem of the day. Explain in your own words what domain restrictions are and why they are needed. All right. Think about fractions, think about even roots like a square root, so on and so forth. All right, so we have function operations. What happens if we start to do addition, subtraction, multiplication, division? As of right now, what we only focused on was just substituting or evaluating it, talking about domain. So once again, why we could use other letters besides f is because if I want to designate between two different functions, I have f and g. You can use any letter you want. Usually f and g are the first two common ones we use. So if I'm doing addition, f of x plus g of x, we would do what? 5x plus x plus 2. Don't forget, the positive would distribute to both, which would give us 5x plus x plus 2, giving us the final answer of 6x plus 2. So the first part of this lesson is just following the operations necessary. All right, so we do subtraction. All right, so 5x minus x plus 2. Don't forget to distribute the negative to both. Becomes 5x minus x minus 2. Combine like terms. You'll get 4x minus 2 as my final answer. Multiplication, all right. We get 5x times the quantity x plus 2. Don't forget that you'll actually have to distribute 5x to both. And I get 5x squared plus 10x. I can't simplify or do anything else, so that is my final answer. Now with division, 5x over x plus 2. Sometimes division is nice because there's nothing else I can really do with this other than put over a fraction. But what do you notice here? I do have a fraction. What do we notice about the denominator? If we think back to the previous lesson, the denominator cannot equal 0. So we have a little restriction. Instead of me saying all real numbers except x equals 2, the shorthand way to do it is saying x cannot equal 2. So we need to focus on our domain restriction as well to make sure everything is covered. All right, so let's look at another example. This time we have exponents that are rational. Let's see what happens here. We have f of x and g of x. Find the following. F of x plus g of x. We add them. Positive, negative, don't forget, becomes negative. So now what we will do is we'll take the coefficients. They both have x to 1/3. So we'll take the coefficients, 5 minus 11, which is negative 6. Attach x to 1/3 power with it. All right, so let's do the minus form, subtraction. Minus the negative is a plus. 5 plus 11 is 16. X to the 1/3. Example 5, we have two more functions. We'll do multiplication first. So that means I multiply 8 times 2 is 16. Don't forget, multiplication means we add exponents, so we still need our exponent rules. Don't forget that that's x to the first power. I wrote it there for you. 1 is the same as 6 over 6. 6 plus 5, the numerator, you get 11 over 6. Now, do you see how, excuse me, there's a 6 in the denominator. 6 in the denominator means an even root. So there's one thing we actually have to add here. X has to be greater than or equal to 0. Do you remember how we did even roots? That would be greater than or equal to or less than or equal to. So greater than or equal to 0, because of the 6 here, you might want to make a note. This is why. All right. Now you might say, well, how come there's no restriction on these two up here? What's my denominator? 3. 3. They're odd roots. Odd roots have no restrictions, only even. All right. So let's look at the next one with division. And that's a fraction bar there. Hopefully you can see that. I'll rewrite it actually. Sometimes it doesn't like to show up. So what I'll do next, 8 divided by 2 is 4. Then I do one exponent minus 5, 6, because remember we subtract when we divide with our exponent rules. Same as saying 4 x to the 6 over 6 minus 5 over 6. 6 minus 5 is 1 sixth. Once again, we have an even root. 6 is even. So there's that restriction, x has to be greater than or equal to 0. Next example, we're going to evaluate. So just like we evaluated before in part 1, we're going to evaluate again. But this time we're going to add something to it where we're going to add or subtract, divide, multiply, whatnot. So we're sort of combining what we did just in the last slides to what we did in the previous lesson. So this is h of 3 plus g of 0. So every time I see an x in the h, I plug in 3. Every time I see an x here, I plug in 0. So we plug in our numbers. Simplify each parenthesis using order of operations. And get negative 3. That's my final answer. So make sure, if I'm going a little fast here also, that you pause and copy it down or try to do it yourself. Here we plug in 5 for the f function. Here we plug in 3 for the g function. And subtract them. And like I said before, I like to simplify the parenthesis first. 4 times 5 is 20 plus 2 is 22. 2 times 3 is 6 plus 4 is 10. Then I actually perform the operation at the end. We get 12. I think it's easier that way. Next one. Plug everything in. Don't forget, 16 to the 1/2 is the square root of 16. That's 4. I also evaluate the bottom. 2 times 3 is 6. Now, how we evaluate fractions is we simplify numerator and denominator to as one number, and then you divide. 4 plus 2 is 6. 6 divided by 6 is 1. That's my final answer. All right, that's it for part 2. Make sure you write out the problem of the day. Also complete the following problems on assignments 9 and 10. Once again, there are 3 problems on each. In class tomorrow, we will finish the rest of assignments 9 and 10.